All right, hey scholars, I'm so excited. We're doing lesson 6.5 here. It's our last lesson for regulars. It's the second to last lesson from chapter 6 for honors, advanced. I'm still trying to changing my vocab here. But we're going to work with kites and trapezoids, the non-parallelograms. Yesterday's were all special parallelograms. These are going to be ones that are not going to be parallelograms. So our very first one is what a kite is. Now understand, a kite is a quadrilateral with exactly, that's the C there, exactly 2 pairs of congruent consecutive sides. So when you have a kite, the first thing you should always do is mark your congruent sides. It looks seriously like Charlie Brown's kite. Now when we were going into detail in class, I started asking you guys to draw diagonals. And you notice the 2 diagonals are going to be 2 different lengths. You have a shorter one and a longer one. Long, short. It normally works out that way every time. But we have some cool properties that happen with kites that we have to use. So the very first one, and make sure we know these again, I'm trying to use highlighters a little bit more in my life just to make sure we emphasize points. But we need to make sure we have these down. These are things we're going to mark real quickly. First one is if a quadrilateral is a kite, then its diagonals are perpendicular. And the reason why is way back in chapter 5. In chapter 5, we talked about if a point was the same distance away from the endpoints of a line segment, it has to lie on the perpendicular bisector. So that's where we get our right angle. And yes, it will bisect the smaller diagonal, the short diagonal, but it won't bisect the larger one. So that's why we don't emphasize it being a bisector. But that's a natural thing that happens. Plus, I hope you realize you can see a whole bunch of isosceles triangles that we're using. So that's the first property. Huge to know. In fact, it helps us a lot when we're finding area later. So remember, if a quadrilateral is a kite, then its diagonals are perpendicular. If a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. Now, which pair is that? It's the pair right here that's formed, and look, if I drew it this way, you can kind of see it with the long diagonals. It's the 2 non-congruent sides angles. And the reason why that works is because of congruent triangles, and corresponding parts of congruent triangles are congruent. Right? I don't know how many times I made you guys repeat that last semester, but it's huge that you know those. We had one other thing that I asked you guys to know, and it's kind of, I called it R theorem, but it's kind of cool. One thing we know about this long diagonal, it will bisect these 2 angles. So I actually will draw it here so we don't get the diagrams confused, but if you have a kite, it will bisect this pair and these 2 pairs. They will be bisected. Because again, of course, corresponding parts of congruent triangles being congruent. So I would just say the long diagonal will bisect angles. It's just a quick way of doing that. It helps us solve for stuff later. All right, let's just do some examples with kites on this page. First thing they tell you, it's a kite, so I always go ahead and mark the pairs of congruent adjacent sides. Then I always label the information I know after that. But first, what do I know about the diagonals of a kite? That's right, forms right angles. Then I start labeling in what I know. I know that the measure of angle DAB is 54 degrees. I also know the measure of angle CDF right here is 52 degrees. Now, I want to know the measure of angle BCD. This one right here. Now, how can I go about doing this? Well, there's a couple different ways that you can do this, and both are right. One way that most people see first is they sit there and see like, oh, this big isosceles triangle. And I know that those 2 base angles are going to be the same size. The diagonals bisected, but not even bisected, just the isosceles triangles work. So I can solve for this missing one. And I can go the measure of angle BCD is equal to 180 minus 104, which is 76 degrees. Now, here's another way. Do you see that right triangle? These two angles are complementary, which makes this one 38 degrees. But I know the long diagonal bisects angles. So I could also go 2 times 38 to equal 76 degrees. I don't care which way you do, as long as you get it right. Be mathematically correct. Okay, let's do this next one here. It says find the measures of the numbered angles in a kite. All right, the sides are already marked for you, but what's the second thing I always want you to remember to mark with a kite? Your right angles. Okay, and another question that's always asked is what's 51 pointing to? This top angle up here. So let's find the measures of the angles of the kite. What's the measure of angle 1? Obviously it's 90 degrees. Why? Because of the diagonals are perpendicular. Now, how's the fastest way to find the measure of angle 2? I'm going to tell you right now. Base angles of this isosceles triangle. So the measure of angle 2 is going to be 51 degrees. Now, for the next one, really what I'm going to use is the right triangle idea. So this one was the isosceles triangle. Now to find the measure of angle 3, I'm going to use the fact that these three angles add up to 180. So I'm going to go 180 minus 90 plus 51. So 180 minus 141, which is 39 degrees. Hopefully that gives you a quick start on that one.